Welcome back to the Foundry by Forge College. Let's just jump right in, shall we? In our previous explainer, we laid down some pretty serious groundwork for your infrastructure. But today we're taking a massive leap forward. We're getting into mapping conditional deployment flows, which is literally a core pillar of advanced deployment strategies on Solana. You know, if you've ever wanted to give your scripts actual intelligence so they can make safe routing decisions on the fly, well, you are in the exact right place.
To really set the stage here, let's connect this back to our previous lesson, from manual steps to scripted workflows. We learned how to turn those tedious manual steps into automated scripts using some basic safety gates, right? Like dry run flags. But let me ask you a question. What happens when that automation basically has no brain? I mean, just imagine the sheer, heart-stopping terror of a script blindly copying untested, broken code straight into your production environment, all just because someone hit execute. Yeah, no thank you. It's kind of like giving a toddler the keys to a sports car. Sure, automation without decision points is incredibly fast, but it is dangerously ignorant.
Okay, let's dive into this. Here is our engineering blueprint for today. Number 1, welcome to conditional flows. 2, core conditional patterns. 3, building a decision matrix. 4, the bash code walkthrough. And finally, number 5, golden rules and wrap up.
All right, Section 1. Welcome to Conditional Flows, moving beyond basic scripts. So, we're going to introduce the whole concept of explicit decision points into our automation. We need to make sure our script knows exactly when to take path A versus path B. Basically, a conditional deployment flow is the specific set of patterns and decision matrices that determine the exact path your scripted workflow takes, based entirely on your scenarios and constraints. Honestly, think of these conditional flows like the most rigorous, intimidating bouncers at an incredibly exclusive club, right? They check IDs, which in our case are environment variables, they direct the VIPs straight down the red carpet to production, and they literally throw out the bad actors, like missing artifacts, before they can even get in the door and cause havoc.
Moving right along to Section 2, core conditional patterns, the bouncers of your code.
Now, in deployment logic, almost everything really just boils down to a handful of repeatable patterns: guard clauses, environment-aware branching, staged releases, pre-deploy validation, and rollback triggers. And this brilliantly illustrates how we map different operational scenarios to their preferred conditional patterns. For instance, if you're doing rapid internal iteration, say just messing around in dev, you absolutely want environment branching triggered by a really simple environment flag. That keeps things fast with minimal verification. But what about an external release to public users? Oh, for that, you want a canary release triggered by specific success metric thresholds. And for a super-critical production change where downtime is just completely unacceptable, you're looking at a blue-green deployment triggered by a passing health check. Emphasizing these trigger conditions is absolutely crucial. It gives you the framework you need to always pick the exact right tool for the job.
To really help visualize these staged releases, let's take a look at this traffic distribution for a canary release. Do you see that tiny 5% slice? That represents the actual traffic getting your newly deployed code, while the remaining 95% of your users stay safely tucked away on the old, stable version. By doing it this way, you're sending a change to just a tiny fraction of users to safely test the waters. If your monitoring metrics look good, awesome, you commit fully. But if things break, well, you've only impacted 5%, and you can roll it back instantly. It's a real game changer.
Next up, Section 3, building a decision matrix, the rulebook. Okay, so we've seen the individual patterns, but now we actually need to combine them into a rock-solid deterministic rulebook. There are 4 sequential phases to creating this matrix. First off, you got to enumerate your imports. You need to literally list out the signals your script can read, like branch names or tags. Inventorying your inputs right away avoids any of those nasty hidden assumptions. Second, you rank your constraints, things like your allowable downtime. Third, you map your actions, filling out each cell in your matrix with an explicit decision like skip, canary, or full deploy. And finally, step 4, you specify verification and rollback. Because for every single action, you absolutely have to attach a measurable check and an explicit, hard numeric threshold for exactly when to abort.
Let's look a bit closer at why understanding your constraints is just so vital. Compare a dev environment with prod. Dev constraints are, well, they're extremely permissive, right? You have a super high downtime tolerance. Honestly, you could literally drop a database in a staging environment and it's mostly fine because there's 0 active user traffic. But prod constraints? Completely different story. Low downtime tolerance, mandatory feature flags, and incredibly strict safety gates. Ranking these constraints really dictates why staging allows for chaotic, destructive migrations, while production demands those cautious, staged releases we just talked about.
All right, Section 4, the bash code walkthrough, the blueprint in action.
It is finally time to shift our focus to the practical application and see how we actually translate our human-readable matrix into a real executing bash script flow. So the absolute crucial point here is this specific evaluation order in your code. You must, and I mean must, evaluate conditions starting from the cheapest, static checks, down to the most expensive, dynamic verifications. Guard clauses come first, always. Then environment branching. Then pre-deploy validation. Then you actually execute the mapped deployment action, and finally you handle your verification and rollback logic. Now, why do we do it in this exact order? Simply because cheap static checks should reject bad inputs early, long before you ever reach that expensive phase where actual state changes are even possible.
Let's examine those cheap static checks first, the guard clauses. In your bash script, these are written right at the absolute top. Their entire job in life is just to fail fast and early. If a required parameter, like your environment variable, is completely empty, or if your required build artifact is literally just missing from the directory, the script just aborts right then and there. It throws out the bad inputs before any destructive action happens. It is your very first line of defense. Right after that, in your script's flow comes environment branching. Now, this is usually a central if-else block that safely routes the dev path far away from the prod path. For instance, if the environment is prod, it branches into checking if the mode is canary or full. The absolute best practice here is to keep these branch bodies really small. Utilize external tools or pipeline steps for the actual heavy lifting of the deployment logic rather than writing massive inline commands. Let me tell you, doing it this way improves your script's overall readability and testability immensely.
And finally, Section 5, Golden Rules and Wrap-Up, your deployment contract.
Let's go ahead and summarize today's explainer and get you fully prepared to operationalize your new intelligent deployment workflows with absolute confidence. Here are your 3 golden rules. 1. Separate your decision inputs from your actions by using a documented decision matrix. 2. Always order your checks from cheapest to most expensive to massively reduce your blast radius. And 3. Treat verification and rollback as paired contracts. They go together. By the way, organizing your logic this way is exactly the kind of foundational engineering practice we explore across the wider learning programs at Forge College, where we absolutely love helping developers master these types of operational skills.
I actually want to read this quote aloud, taking it nice and slow, because it is literally the absolute bedrock of advanced deployments. Here it is. Every automated action you allow should have a measurable verification point and a documented rollback path. Seriously, this paired contract is the ultimate safety net for any strategy you implement. Never ever assume a deployment succeeded just because the script finished executing. Measure it and always know exactly how to reverse it.
I want to end with a provocative question, just to get you thinking a bit. Now that you have this beautiful, completely deterministic decision matrix in place, how will you handle retries without breaking it? I mean, what happens when a random temporary network blip interrupts your flow? Well, that is exactly what we're going to tackle in our next module on robust error handling. Until then, make sure you visit forge.college to learn more about this subject and explore our other amazing Web3 related topics. Thank you so much for hanging out with me on this explainer, and hey, happy deploying!